Today we're going to explain how a car airbag works and the chemistry that makes it inflate in literally a few milliseconds. When the car detects a crash, it sends an electrical signal to the inflator, and the first reaction happens almost immediately.
Sodium oxide breaks down into nitrogen gas, which is the one that actually inflates the bag. But another reaction is created, which is metallic sodium, which is harmful to the skin because at the touch with the skin creates burns in the skin. So another reaction is needed, which is potassium nitrate, which mitigates the reaction of metallic sodium.
Potassium nitrate is a strong oxidizer, and the oxides, sodium and potassium oxide, from here are corrosive. So the inflator also contains materials like silicon dioxide to turn everything into stable, safe silicates. In the end, the only thing that actually reaches the passenger is cooled nitrogen gas.
Now, for the volumes and calculations. A typical driver's airbag is about 63 liters in capacity, and the passenger one is about 135 liters in an SUV. Using the ideal gas law, we determined the nitrogen needed to fill them. That was 53.7 grams for the driver's airbag and 115.6 grams for the passenger's airbag. To find how much sodium acid was required, we converted those masses to moles and applied the ratio from the original reaction, or the first one. This gave 83.2 grams of sodium acid for the driver's airbag and for the passenger one 178.8 grams. From that same reaction, we obtained the mass of metallic sodium formed, which was for the driver 29.4 grams and for the passenger 63.3 grams, which must be neutralized. That's where the second reaction enters. We calculated the potassium nitrate needed, which was 25.9 for the driver's airbag and 55.6 grams for the passenger's airbag. That reaction also produces extra nitrogen, giving 3.6 grams more for the driver's airbag and 7.7 grams for the passenger's airbag. Once adding everything together, the total nitrogen inside each bag is for the driver's 57.3 grams and for the passenger 123.3 grams. To determine the energy involved, you first write the balanced composition of sodium acid into sodium metal and nitrogen gas, then obtain the standard enthalpy of formation for sodium acid. After converting the exact mass used into moles, you apply the reaction enthalpy to quantify the energy change.
So basically, in under 40 milliseconds, all these reactions produce enough nitrogen to inflate a huge cushion while turning all the dangerous stuff into stable, harmless materials. Chemistry literally saves lives in a fraction of a second.